Hi guys. Okay, so today we're going to be talking about degree, leading coefficient, and end behavior. Um, we've mentioned the first two of these, degree and leading coefficient, before, and this video is actually going to focus more on the end behavior. But I do want to go over degree and leading coefficient because we will be using that in future classes as well. Okay, to start with, degree. So degree, we talked a little bit in the last video, is the highest exponent in the equation. Also, guys, it's not a bad idea for you to have a notebook out right now and you can be taking notes. That way you pay attention to the video a little better, and you have some notes that you can look back at. All right, so degree, the highest exponent in the equation, no matter where that highest exponent is. Okay, so for example, on these examples here, so we have 4, 3, and 2. So obviously 4 is my highest one, so my degree on the first one would be 4. For the second one, notice it's 2, 4. That has an exponent of 1, and then that one doesn't have an exponent at all. So 4. So it's not always the very first term, especially if it's not written in order. Now, this right here, this first one is called standard form because it is written in descending order. So if it's written that way, then you can always look at the first one, but sometimes they're not written that way. So that's why here it was in the middle. Next, we have to the 9th, to the 2nd, to the 4th. So our highest power here is 9, so this is degree 9. And then finally, this one is our basic quadratic, right? So this would be 2, and that would tell you that it's a degree of 2. Remember that whatever the degree is, that's how many zeros or solutions that polynomial has. Okay, so for example, we've been doing quadratics. We had 2 answers, or 2 times that it crosses the x-axis. Okay, now if we're doing it from a graph, we're looking at how many turns there are, and then we add 1. So for example, it's going up and then turns and goes down. So this is a turn. So there's 1, there's 2, there's 3 turns in this graph. So 3 turns, and then we add 1. So this is a 4th degree function. Okay. Again, if you want to look at, it would cross the x-axis 4 times. So notice here, 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 and obviously as this would keep coming down, it would eventually cross the x-axis for the 4th time. Okay, so that's degree, the highest exponent in the equation. All right, and the next thing we're going to talk about is leading coefficient. Okay, so coefficient is the number that goes with the letter, right? So if I had 4x, my coefficient is 4. Okay, so when we're saying leading coefficient, we're saying the coefficient or the number that is with the degree, which is the highest exponent. So you find the term that has the highest exponent, and then whatever number is in front of that is your leading coefficient. Again, if it's written in standard form, like this first example is right here, this one's written in standard form, so therefore it's going to be your very first number here, so 4 is your leading coefficient. For this example here, notice that our degree is going to be 5. So that means the coefficient or the number that goes in that term is going to be your leading coefficient. So here it would be 10. Here, our leading coefficient would be 4 because my degree is 1, right? There's really a 1 there, so the first power. So that is going to be the number that's with our leading, or with our degree. Over here, 3, 4, 6. So 6 is my highest power. So then the number that's with that, so that's 5. So that's leading coefficient is 5. Here, this is a basic quadratic again. Notice that our first is that this term is negative. So my leading coefficient here is -3. And then down here, my leading coefficient is going to be -8 because 4 is my biggest exponent. So that's the degree, and it's whatever number is there. Now, if we had f of x equals x to the 4th, 2x squared plus 5. All right, so 4 is our highest exponent, so that's our degree. There's no number here, but what number's really there? We just don't write it. A 1, right? Exactly. So my leading coefficient here would be a 1. Okay, so just make sure you pay attention to that. And then likewise, if this were negative, right, then my leading coefficient here would be -1, okay? All right, so that's just a quick overview of those two vocab words. And then the main stuff that we're going to be working with now is called end behavior. So in which direction do the ends of the graph go? That's what end behavior is. Where do the ends of the graph go? Okay, so graphs have two ends. They have a left end and they have a right end. Okay, and that's what we're focusing on, is the two ends of the graph. So you can see I kind of labeled them here with left end and right end. Okay, so we are focusing on this arrow and this arrow. We really don't care what's going on in between. There's going to be a lot that happens in between. These are two pretty basic ones. Sometimes you can have graphs that just keep going up and down and up and down. It doesn't matter. We're only concerned with the ends of the behavior, or the ends of the graph. Okay, so that's all we're looking at. When we write end behavior, it's going to look like this and look like this. Okay, and that looks really intimidating, but I promise you it's not bad at all. So we're going to talk about that. So when we talk about end behavior, I want to know, where do the ends of the graph go? You have two options for that. The ends of the graph can either go up, like these three, or the ends of the graph can go down. So you only have two options. It's either up or down. Okay, so that's what makes this a little bit easier. The way we write it out confuses students more than just simply looking at the ends of the graph. Okay. All right, so let's take this back a little bit. Let's look at this. Okay, so we all know that a coordinate plane is just a number line that is horizontal and a number line that's vertical, and we just put that together and that makes a coordinate plane. Okay, so if we are going to focus, let's just focus right now on our horizontal coordinate plane. Okay, so if I was looking at this and I asked you, if I wanted to go the way of negative, which direction would I go? Would I go from right or left? So of course we would start at 0, right? If I wanted to go negative, which direction would that lead me? Would it lead me to the right, or is it going to lead me to the left? It's going to go to the left, right? So as we move left, we get more and more negative. We get smaller and smaller, right? So we call this negative infinity, okay? So if you're moving left, it's called negative infinity. So left equals negative infinity. Sorry, my infinity signs are not happening today. All right. Now, if we wanted to move right, okay, if we're moving right, that means that we're going positive. Okay, so if we go to the right, we're going to positive infinity. Okay, so just think of it as a basic number line. Okay, so when we write this out in the way that we write this, so we have x, we always write it as x goes to negative infinity, and then as x goes to positive infinity. So as x goes to negative infinity, what we're talking about is this side, right? So all that means is we're talking about the left arrow, right? We said that on the graph you have two arrows, you have a left and a right. So we're talking about negative, we're talking about what's happening on the left arrow, right? Also, think of this when we read a graph from left to right, just like you read a book from left to right, you're going to hit the left arrow first, and then we move over to the right arrow. Okay, so it's the first one. And then when we say as x goes to positive infinity, we're talking about the right arrow. Okay, and then we're just going to tell what those arrows are doing. Okay. All right, so that's the horizontal. That's the x, right? This is my x-axis. Okay, so now let's look at the other way. So if we go this way, we're talking about our y-axis, right? So if I start at 0, if I go up, what does that mean? Is that going to positive or is that going to negative? Well, obviously, if we're going up, then we're going to positive, right? So this is going to be our positive infinity, means up, right? So positive infinity equals up, okay? Then obviously, if we go down, right, that's going to tell us that we're going to negative infinity. So negative infinity means down. So instead of using the words left and right and up and down, we are using the infinity sign. Okay? To go left, we're saying negative infinity. To go down, we say negative infinity. To go right, we're saying positive infinity. And to go up, we're saying positive infinity. Okay? So that's really, 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 really important for you to understand. So one more time, and you might want to write this down in your notes. Write this on a sticky note somewhere so as you're doing your work. So negative infinity is going to take us left, and then negative infinity takes us down. Okay? And then positive infinity is going to take us right, and positive infinity is going to take us up. Okay? It's super, super important that you remember that. And then obviously, left and right, we're talking about the x-axis here. And when we're talking about up and down, we're talking about the y-axis. Okay? All right, so how do we find end behavior? So how do we do this? Okay? So if this was our example here, this was our problem here, okay? Every single problem of end behavior will always start off with this right here. Every single time, no matter what, this will never, ever, 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 ever change. Okay? So as x goes to negative infinity, y is going to go where? And as x goes to positive infinity, y is going where? Okay? So that's what we're going to look at our graph for. So remember, we said that if we are pointing at x, right? X is left and right. So if we're saying to negative infinity, I'm referring to the left-hand side. So this is referring to the left arrow. So this right here, that's what that is referring to. So what we're saying is, what is this end of the graph doing? Okay, so it's going up. Now, we said up is going to be positive or negative infinity. It's going to be positive infinity. So right here in our answer, as x goes to negative infinity, so we're saying the left-hand side, the y, what's happening to the arrow? It is going to positive infinity because it's going up. Okay? Now, the second one here, as x goes to positive infinity, so now we're referring to the right-hand arrow. Okay, so in our class, we're always going to do the left-hand arrow, then the right-hand arrow, because it's like you're reading a book from left to right. It's what we're naturally used to doing. So now this arrow is going down. So we said if we go down, right? If we go down, that means I have negative infinity. So as x goes to positive infinity, y is going to negative infinity because it's going down. Okay? Up, positive infinity, down, negative infinity. Your only answer choices for these is going to be negative or positive infinity. Those are your only two answer choices. There is no other answer choice. Okay? If it is going up, if the arrow is going up, then we say it goes to positive infinity. If the arrow is going down, then we say that is negative infinity. Okay, so let's practice some of these. All right, so if we're looking at this. So again, this first statement here, as x goes to negative infinity, remember that's referring to the left-hand side. Every single time, left, then right. Okay, all right, so on this one, we have as x goes to negative infinity, notice that my arrow is going down, so this is going to go to negative infinity. As x goes to positive infinity, so we're talking about the right-hand side, it's going up, so that's going to positive infinity. Feel free at any time to pause the video and take a screenshot of these. That way you have some examples when you start doing your work. All right, for this next one, so as x goes to negative infinity, so we're talking about the left, my y is going to positive infinity. And then as x goes to positive infinity, so we're talking about the right-hand side, this is also going to positive infinity. Okay, so again, this is the left one, this is the right one. Okay. All right, as x goes to negative infinity, so we're going this way, my arrow is going down, keeps going down. So this is going to be negative infinity. And then this, as the arrow goes up, or I'm sorry, to the right, it's going to positive infinity. Remember, left and right arrow. Every single time, left and right. So notice this one, the left one is going down, so this is negative infinity. The right one is also going down, so negative infinity. Okay, let's do a couple more examples. All right, so here, the left-hand side is going up, so that's positive infinity. The right hand is going down, so that's negative infinity. Okay, again, left to right, arrow. Okay, the left arrow here is going up, so that's positive infinity. This arrow, the right hand arrow, is going down, so that's negative infinity. Here, the left hand side is going up, so that's going to positive infinity. The right hand side is going down, so that's going to negative infinity. Again, left and right. The last one here, so we can see how we get really crazy in between? We don't care about any of this. We only care about these two parts right here. That's the only part I care about. I don't care what the graph's doing in between. It could be doing all sorts of crazy things. I'm just looking at the end behavior. So as x goes to negative infinity, y, or the arrow, is going down, so it's going to negative infinity. And then as you go to the right, so as x goes to positive infinity, we're talking about the right-hand side. This one is also going down, so it's negative infinity. Okay? So again, the first one is telling you the left arrow. The second one is telling you the right arrow. Okay? So negative infinity is referring to the left. Positive infinity is referring to the right arrows. And then when we're talking about, this is when we have x's, right? And when we have y's, negative infinity is referring to down. Positive infinity is referring to up. And that's the direction of the arrow. Okay? All right, hopefully this makes sense. If not, please feel free to reach out to me. The next lesson, we're going to be looking at, if I just give you an equation, not the graph, if you can tell me what the end behavior is what's going to happen. So just by looking at your leading coefficient and looking at your degree, that's going to tell us how to do that. Okay, so that will be next class. So make sure you understand this, because if you don't understand this, it'll make next class super hard. Okay? All right, guys, if you have questions, please feel free to reach out to me, and we'll figure it out. Thanks, guys. See you later.